Welcome to Absolute Value and Radicals for Pre-Calculus Math 11. We're going to take a look at the unit Multiplying and Dividing Radical Expressions, section 2.4. When we multiply radical binomials, which really just means a two-term expression, we can follow similar techniques that we use for multiplying regular binomial expressions, like we use difference of squares. We also use foiling. So let me just write down FOIL, which is just an acronym for first outside, inside, last. So we can use these techniques. Let's just practice this for radicals. So a FOIL technique would be, let's multiply the first terms. So f times 3 root 2 times root 2. So we get 3 root 4. The outsides, which would be 3 root 2 times 2 root 7. That would be 6 root 14. The insides, which would be negative root 14. And the last terms, which would be negative 2 root 49. So I'm doing it a little bit quicker than usual, trying to speed up the process a bit, doing some of the multiplications in my head. We can certainly simplify this. 3 root 4 is 3 times 2. Root 14 does not have any perfect squares in it, so we can leave those two. Root 49 is 7. So we have 6 root 14 minus root 14, we remember from last podcast, is a combination of the two, and 2 times 7 is 14, and we end up with something like negative 8 plus 5 root 14. So that's foiling. It works exactly the same when we multiply two binomials. Now, you may recall for a difference of squares, what happens is that if the first term in both binomials is the same, and we also have the second term the same, and if they're conjugates, which mean that they differ by the sign, the operator that's in between, that we can FOIL it as a difference of squares. And a difference of squares is, let's take the first terms squared, and we subtract off the second squared term. Now really a difference of squares is just a special case of foiling. When we take 2 root 5 and we square it, we're squaring both the 2 and the root 5 to make it 4 times 5. 4 times 5 is 20. And we have 20 minus 36, which we get negative 16. If we recall, as we expand this idea to include radicals with variables, we still need to consider restrictions. So those restrictions of what we're taking the roots of still apply, where we can't take the square root fourth root of odd numbers, or sorry, negative numbers, and where the cube root and fifth root, it's okay to take the square root, or sorry, the cube root of negatives. Recall that when an expression is multiplied by 1, it remains the same. So to pick out any number, anything, multiply it by 1, still 1. We can use this strategy to change a quotient containing a radical. So a quotient is a division, or an expression where we have two things dividing. This process, known as rationalizing, so we're going to rationalize, can be used to rationalize either the numerator or the denominator. So the process of rationalizing can be used for either the numerator or the denominator. You'll find in Calculus 12 that it's sometimes necessary to rationalize both. If the radical we are trying to rationalize in a monomial, so a single term, we can rationalize by multiplying both the numerator and the denominator by that radical. So effectively multiplying by 1. So if we want to rationalize the numerator in this example 2, we want to get rid of any radical out of the numerator. And to do so, we are going to multiply by root 3. But because we can't just multiply by a random root 3, we need to multiply by a 1, by dividing by the root 3 as well. So root 3 over root 3, that is effectively multiplying by 1. In the numerator, root 3 times root 3 is root 9. In the denominator, root 2 times root 3 is root 6, and minus root 15. and that simplifies to 3 over root 6 minus root 15. Again, let's check always for any perfect squares in root 6, root 15. I don't see any here, but it's usually a good idea to do that. We can also rationalize a binomial expression. So a binomial expression, two terms, which contains a radical by using a difference of squares. So a difference of squares, if we scroll up, to this first example we did here with the difference of squares, notice how when we had a difference of squares that we no longer ended up with a radical. We ended up with negative 16 as an answer. So if we scroll back down, we still multiply the quotient by 1, but we need to multiply by the conjugate, is the term we're looking for there. And the conjugate of the binomial. The conjugate is just the same expression, but we change the sign of the operation so that the multiplication becomes a difference of squares. So what that means is, if we have root 2 minus 3, its conjugate would be root 2 plus 3. So the exact same binomial, just the opposite sign or operator in between. So we have a couple of examples here, fairly straightforward in terms of rationalizing. I'll take care of the first one here for you. 5 over root 3 plus 1. So we're trying to rationalize the denominator in this case. So we want to multiply in the denominator by its conjugate. So root 3 minus 1. And because we can only multiply by ones, let's do so in the numerator as well. In the numerator, we end up with 5 times root 3 minus 5. In the denominator, because this is a difference of squares effectively, we can deal with it as such, root 3 squared minus 1 squared. So we end up with 5 root 3 minus 5, and in the denominator we end up with 3 minus 1, which is 2. So 5 root 3 minus 5 over 2. How about you try B, root 2 over root 3 minus 7, root 7, see if you can rationalize that. Hit pause now. So what we're going to have to multiply by is again the conjugate, which is root 3 plus root 7. Root 3 plus root 7. Again, we want to multiply by 1. That's the key here. In the numerator, root 2 times root 3 is root 6 plus root 14. In the denominator, again, difference of squares. So that's root 3 squared minus root 7 squared. And we end up with root 6 plus root 14 in the numerator. 9 minus 49 in the denominator, which works out to be negative 40. So root 6 plus root 14 over negative 40. So as long as you remember what the conjugate is, which is really just the binomial, same binomial, but with a change in the sign, fairly straightforward process to rationalize. How about go ahead and try rationalizing the numerator? In this case, because I'm asking you to rationalize the numerator, we're going to multiply by the conjugate of the numerator, which is 2 root 2 plus 3. So the questions are getting a little bit bigger, a little bit more involved, a little bit more multiplication involved. The numerator now becomes a difference of squares, 2 root 2 squared minus 3 squared. Our denominator, we don't have too many options here. We actually have to FOIL that out. Root 5 times 2 root 2 is 2 root 10. The outsides would be 3 root 5. The inside would be 2 root 4. And the lasts would be 3 root 2. In the numerator, 2 root 2 squared, we would square the 2 to make it 4, and the root 2 to make it 2, minus 9. We have 2 root 10 in the denominator, 3 root 5, 2 root 4. Root 4 is actually a perfect square of 2, so 2 times 2 is 4, and 3 root 2. In the numerator, we basically have 8 minus 9, which is negative 1, and we just can't really reduce that denominator at all, so we're just going to leave it as is. Now, it's not terribly pretty. Rationalizing the numerator, rationalizing the denominator, doesn't matter which way. Really, you just always want to multiply by the conjugate. And when I say conjugate, remember you're multiplying by 1. This ends the notes for multiplying or dividing radical expressions, section 2.4.